For the next half hour here, we're going to be talking about APIs and MCP, specifically how to take existing REST APIs that you've written in .NET and to add MCP capabilities to that. If you're not familiar with MCP, we'll be talking about what that is and what it allows you to do. As Javier said, I'm Jonathan Tower. I go by J for short, and I've got my contact info here. I'll show that again at the end. I'd be happy to connect with anybody who has any questions today from the content that we're talking about. So just to start out with kind of the inspiration for this talk, at Trailhead, the consulting company that I helped found and currently work for, we have a lot of clients that are that have existing APIs, usually REST APIs, in the sense of that we do a lot of .NET. A lot of these are .NET REST APIs, ASP.NET, and those things are allowing other systems to talk to each other. They're allowing front ends to talk to back ends, whether that's mobile or desktop or web applications. All of those things right now exist out there, and a lot of our clients already have this. But now a lot of them are really trying to figure out how they can AI enable the technology stacks that they already have without kind of reinventing everything. And so that's kind of the inspiration for this talk is how can you take these APIs that you already have your front-end applications talking to and allowing you to then to access other back-end systems and databases and things and kind of add just sort of a bolt-on to those APIs that gets you from 0 to 100 really quick on being able to give AIs, whether that's agentic AIs or just the classic chat AIs that we've all been using for a couple of years now, to give those access into that same data and functionality that your other applications are able to get through those APIs that you already have. So that's kind of the inspiration for this. If you're like me and you kind of need examples to understand some abstract concept like this, here's a few that I just threw together that I think are very realistic scenarios that are happening today. Some of these are the types of things that we're helping our clients unlock right now. So imagine you're creating a sales assistant that's helping you update data in your CRM and scheduling follow-ups automatically and updating you with reports and briefs and things on your sales process and your contacts. Maybe a chatbot that's helping you run reports or collect data from around your organization and give you different key performance indicators about how things are going, and maybe even proactively reaching out to you to say, hey, have you looked at this key performance indicator? I think there's a problem going on right now. As an owner of a consulting company, I really feel this one. We're always trying to keep an eye on certain key performance indicators, how happy our clients are, how much of our time we're billing. All of those things are really important to keep an eye on. How useful would it be if that data was just basically, accessible to like an agent, and that agent was coming to me and telling me proactively to take some action because some KPI is out of whack. Customer support copilot. This is a really popular one right now. So customers, calling in, and something like 80% of those calls or those chats that are coming in are the same few things, telling them to reboot their router or asking, questions about orders and shipping dates and all of those kinds of things. And if you could hook into some of those underlying systems and answer a lot of those questions without the need for human interaction, that would be huge savings and also make things easier and more pleasant for your users. Document generation, maybe you're taking templates and then data from different systems and merging that data into those templates. That's something that agents and chatbots are really good at doing. Procurement flows, so it's time to reorder this stuff, creating POs automatically, double checking budgets and routing approvals to the correct people. And then obviously things like scheduling are a really natural fit for AIs to do for us, coordinating calendars, proposing times, sending out invites, etc. So these are all the types of things that you could unlock, and thousands of other examples if you need examples to kind of wrap your head around it. So in our time together, I want to do basically 4 things. I want to talk, first of all, about what MCP is. Probably a lot of you are already at least somewhat familiar with this. Maybe you've seen some of the other talks earlier today or the last couple of days here about MCP. but we're just going to kind of make sure everyone's on the same page about that before we move on. Then I want to talk a little bit about how MCP and REST are similar, but also different from each other. So if you're already familiar with RESTful APIs, you might be already thinking like, isn't MCP just like REST for AIs? We're going to talk about that and answer that question, which of course the answer is yes and no, or it depends, like any good engineer would say. Then we want to move on to the main tool that you're going to use to actually create your own MCP server, which is the MCP C SDK, which has been out for a little while now and releasing new versions, but is releasing a new version here along with .NET 10. And then I want, of course, show you a demo of all of this good stuff happening in a kind of a realistic application. So that's the plan for today. This is me again. Here's some contact information for me if you're looking to connect with me. I've also got this QR code and bit.ly link if you want to just reach out a simple way, put some time on my calendar. And then the last thing on this slide, which I will show again at the end, is just a place that you can find all the code and slides that we're looking at in this talk on my GitHub. All right, so to start out with, just a quick introduction to MCP. So this is a definition you'll find of MCP on the internet, various places. Of course, what does it stand for? Well, MCP stands for the Model Context Protocol. And this is actually important to know that it's an open source standard. So two important things there. Number one, it's open source. That means this doesn't belong to any one company. Nobody can like pull the rug out from under you if you implement MCP and suddenly say you have to pay for it. This is something that's out there in the community. And then it's a standard. It's just basically a protocol that allows all kinds of different systems from all kinds of different companies and backgrounds and creators to speak with each other. And this was introduced by Anthropic about a year ago at this time. And it was introduced as a way for connecting AIs, and that could be chatbots or LLMs or agentic AIs to external systems. So that could be any kind of underlying system. What does that look like? Well, if you go to the modelcontextprotocol.io, which is the website for the spec, you can see this diagram here where they kind of lay out some examples of what this looks like. So on the left side, you've got here all kinds of different AIs. This could be ChatGPT, or it could be Claude, or it could be an agent, or it could be just an LLM, or it could be a development tool like VS Code, all kinds of different things over here on the left. And then in the middle is this protocol that allows all of those things to speak with all the things on the right. And you'll notice that this MCP standardized protocol is bidirectional, meaning that information can flow in both directions from the underlying systems to the LLMs and other AIs, or from the AIs back into the systems, can make updates basically. And then what are they connecting to? Well, basically anything that you can write an MCP server for. So that could be underlying data systems like file storage or databases. It could be different development tools or SaaS products like GitHub. It could also be various productivity tools. You could imagine a scenario where in the future all of the airlines and hotels have MCP servers, and you can just ask your LLM to go like find the best deal at a place that meets certain criteria that you're looking for. Maybe you want to have free parking or free breakfast or something like that, and you want to keep the price under a certain amount. And it'll go find a place, and maybe even it'll be able to connect to some of your membership information and say, oh, you're a member here and you have these rewards, and maybe you should, I'll book this one for you because of all of those things matching. So that's kind of what MCP is for here. It's for connecting these AIs to these underlying systems and to have that data flow in both directions. So how does that data flow? Well, it flows two different ways, but kind of potentially three different ways. So let's talk about what those transports are. The first and best one when you're in a local scenario is standard IO, just the standard in and standard out. That's available on basically any process that's running on basically any modern operating system from a command line or a console. And those standard in and standard outs allow you to have really fast inter-process communication. And so if you are running an AI on a particular box or virtual box, and you want to be able to connect to a system and an MCP server that's running on the same virtual machine or machine. You can do that through standard I/O, and it's going to be really fast and really secure because it's not going over the network at all. And that's really a great option for those scenarios. But a lot of scenarios are going to be not on the same machine. And so that's what the streamable HTTP transport is for. So this has a couple of different methods that it uses in HTTP. Number one, it's using posts to send data in to those external systems. And then it's using server-side event streams to get data out. So basically long HTTP GET requests, and then it's doing server-side events through those GET requests back to the client. So that allows streaming to work. So this is what you're going to want to do for any remote scenario. And this is also something that, because it's HTTP, it works really well with all of the auth stuff that you might already have that's HTTP compatible. Also works with any kind of proxies or traversing different networks. And then the last one I'll just mention, the spec actually leaves room for there to be custom implementations of transports. It doesn't specify anything about those. And so, that's kind of up to you if you want to create your own custom one for a certain implementation, maybe a proprietary thing for your particular organization or something. But the spec does leave room for that. It just doesn't specify any other details. So the main thing you're going to use is that standard I/O and streamable HTTP. So let's just kind of compare and contrast REST and MCP a little bit, because at this point, if you're familiar with RESTful APIs already, you might be thinking, isn't MCP just basically REST for AIs? And you're not totally wrong, but you're also not quite right. And let's talk about how those are different if you're thinking that way. So first of all, is just the audience that these are for. So a REST API, if you think about it, it's basically programmers that are using this, right? You would not probably send this to your non-technical coworkers or your non-technical family members and say, here's a REST API that you can call. They're not going to know how to do that. So it's really service integrations of other developers. That's the audience that you're thinking of here. MCP, this is meant for LLMs. It's meant for humans, agents, AI agents to use. So it's really meant for a slightly more AI-oriented and non-technical audience. It should be pretty easy to set up. And of course, as the technology evolves, it's only going to get easier to basically just click on a link and say, I want to add this MCP server to my tool. As far as discoverability goes, you might be lucky enough that you've used REST APIs that have implementation of the Open API standard, something formerly known as Swagger. This is a great way to kind of statically document what is existing currently in the different endpoints of an API, but it's not required to have a REST API. You do not need to have Open API documentation. But for MCP, it is required, and it's actually runtime discoverable, and it allows the tools that are the AIs that are calling the tools to get a list of all the tools and resources and prompts that are actually provided from that MCP server, which is cool because it kind of versions itself. So you don't have to do anything special to update all of the AI clients that are using a particular MCP server. When they make a call to that MCP server, they will automatically find out about any tools that have been added or removed or changed in the meantime. The other one is contracts. So when you talk to a REST API, you're going to be using the contract of what's the particular URL endpoint that you're hitting, what HTTP verbs are you using, and then of course those status codes that come back are going to give you information about what actually happened. With MCP, it's particular named tools, and then there's kind of well-known JSON schemas and structured results that you can expect back from them. The invocation and transport of a REST call is going to be over HTTP always, whereas MCP, like I mentioned before, can be either standard I/O or streamable HTTP or a custom transport implementation. When you're trying to orchestrate data from a bunch of different systems, you have to basically custom write that code. Another reason why REST APIs are meant for developers, not non-technical humans, because you have to kind of stitch together all those multiple calls. So maybe you make one call and that gives you an ID. You use that ID in your next call. and so on and so forth. And you're kind of stringing together a bunch of things to make decisions and decide what other APIs to call and what data to send to them. MCP, that can actually be done for you, particularly if you're thinking about like an agentic AI that's calling potentially multiple tools, maybe multiple endpoints in one server and multiple endpoints in several other servers, and has the ability to do some human-like reasoning to decide which of those to call, and based on the response, what other things to call and what to send to each of those. And you don't really have to do anything other than document them well, the tools that is, to get those things to work together. The AI is going to do a lot of that wiring up for you. Streaming, very uncommon in a REST API. It's a first-class citizen in MCP because so much of agentic and AI stuff happens slowly and gradually. You want to be able to get that stuff as it becomes available, all the response data as it becomes available. It's obviously built into REST APIs to do authentication because it's over HTTP. On the MCP side, that kind of depends on your transport. So if you're HTTP, like if you're using streamable HTTP as your transport, then yes, of course, you have auth available to you as well. And so if you think about like the best use, REST is really meant to be the back end for front ends or for integrations as APIs. And then MCP is really meant to be a tool that you can add to an AI that allows it to call into back-end systems. So some similarities and some differences, as you can see. So now let's talk about the MCP C SDK, which is the library that you would actually use to implement your own server or client, MCP client in C#. So this has all kinds of great tools in it. You've got the ability to do clients and servers, as I mentioned. It's got attribute-based discovery. So if you have tools or prompts that you want to expose, you just put an attribute in front of them and they're automatically discovered by your code. It integrates with the Microsoft Extensions AI stuff natively, so it just works. Transports are all included, so standard I/O and HTTP. If you're doing a client and you want to integrate this into certain chats or agents, you can do that very easily with this framework. And then last, I'll just mention that it works with any MCP server because MCP is a standard and this follows that standard. So what's new in .NET 10 with C# SDK for MCP? There's improvements to the auth protocols, so you can do more modern authentication. Allows now what's called elicitation, which basically allows the server to request information from the client. Better structured output from your tools, the ability to include resource links, some schema and metadata improvements to make things a little more human readable, and then some simplified APIs. As the tool and SDK is improved, the APIs get simpler and easier to use. All right, so with all that said, now we're going to jump into the real meat here, which is the demo. We want to actually see this in action. So I've got a real simple API project here. You can see I've got top-level statements, program CS here, and it's just setting up a web application at localhost 5555. And I'm setting up my Swagger endpoints. And then right here is where I actually start to set up MCP. So you can see I'm adding an MCP server. I'm adding that HTTP transport. So I'm using HTTP streaming, not standard I/O. And then I'm also telling it to scan the current assembly for any tools that are registered in there. We'll see what that means in just a moment. And then for my app, I'm again setting up the endpoints in the pipeline for Swagger. Then you can see where I'm actually mapping my MCP server, which is under the /MCP root path. And then I've got some kind of custom code here that's doing minimal APIs, and we'll look at that in just a moment. And you can see I'm mapping all my endpoints right here and then running the application. So let's start with mapping the endpoints. What's that actually doing? Well, if I look at this extension method, you can see here, this is where my mapping endpoints method comes from here. It's a extension method on the iEndpoint route builder. And you can see what it's basically doing is it's looking through the current assembly And it's looking for anything that inherits or implements the I endpoint interface. And then if it finds those, it's basically creating an instance of them and then creating a list of those. So then it loops over that list, and for each one of those, it calls its map endpoints and passes in that endpoints method. So right here, we can see that I've got one endpoint implemented. So here you can see to-do endpoints, which implements the I endpoint interface. And this has got the map endpoints method in it, so that makes it actually implement the interface. And here's where the app gets passed in. And here I'm basically setting up 4 endpoints under the /API root path and then to-dos. And you can see I've got a get, a post, and 2 patches in there. And then those are basically mapped each to a private static method below that is kind of each of those endpoints and is doing those things. And mostly you can see it's using this to-do store. And that to-do store is kind of like a business logic layer or a repository layer that's basically going out and doing these actions to the database. So, getting all of the things, adding a particular to-do, and so on. So that's kind of the program. Now let's look at this in Swagger and see how this actually works. And then we'll look at the MCP configuration. So I'll go ahead and run this, and then we'll open up the browser. So here we are on our Swagger endpoint. And if I just go here to the to-dos endpoint and say I want to try it out and execute, you can see I get back an empty response, just empty brackets there. So I could create a new one here by doing this post method here and say I want to insert one. We'll call it demo at .NET-conf. And by default, let's make sure we spell that right. And then by default, I would want this to not be completed. I want it to be an incomplete task. So we'll put that as false. And I don't really need to specify an ID. It'll do that for me. And so when I execute that, I get back, okay, it assigned an ID of 1, and you can see that it's in there. Now, if I call this get method again, I should get back a single item in my response. So great, my REST endpoints work as expected. Now let's actually look at how I can expose these with just a simple bolt-on to this API. So you remember in my program CS here, I've got the add MCP server, and then it's saying with tools from assembly. So what that's going to do is basically scan for those attributes I was talking about earlier. So if we look at this to do MCP tools CS file, you can see it's got an MCP server tool type attribute on it. And then each of my methods in here has the MCP server tool, and then it has a description. So what each of these do is, first of all, this tells the logic that's scanning through here that this class has tools defined in it. And then each of these methods is a tool and it's being marked that way. These descriptions are also really important. This is actually how the LLM interprets what these particular tools do and what data needs to be passed into them and what data will come back out of them. So the more descriptive and specific you can be in these, the better it'll work with your various large language models. And you'll notice even the attributes or the parameters that are coming in to these particular tools have a description on them. So this is complete, which is a nullable Boolean, and it defaults to null. You can see it's saying filter by completed status, true for completed items, false for incompleted items, or omit to get all items. So we're being very explicit there about how this works and what it should do to, pass in different values there to get different results. And if we kind of just look through this, each of these is just basically doing the same things that each of the API endpoints are doing. But they have a little bit different inputs and outputs. And, maybe I want to apply different business rules in these. So this is a great place to kind of do these separately, but because I might not want to expose all of them. And so I've basically picked and choose which ones I want to do here. And then I can go through and describe each of the parameters and the return types and what each method does. So that's what's going on here. And then the last thing I want to show you is how I can actually call that. So I'm going to go over here to Claude, which I have running locally on my computer. And first thing I'm going to just ask it is, do I have anything to do right now? And it's already been configured to have my MCP tool. So you can see that it's saying, from what I've asked, it's saying, oh, I need to look at your to-do list, and it's calling my get to-dos. And it says, yes, you have one incompleted to do, which is demo at .NET-Conf. Would you like me to mark it as completed once you finished it? And I can say, yes, please do that. I'm just finishing the demo now. And it's going to go ahead and update that through the API that does updates. And so you can see it calling that, and I can actually see the response. And then it says it's done. Now, if we go ahead and execute again here in the API, you'll remember this was incomplete false before, and now it's is complete true. So it basically did that update for me through the MCP server from the AI. And now I can say, do I have anything else to do? And it's going to go call that get endpoint again. It's going to pass in the, only show me the non-completed items, and says, nope, your to-do list is clear. So I've now basically unlocked all of the functionality that these REST endpoints already had. And I've basically made it so that I can now do those same things from MCP server or from a large language model, chat, or agent like this. Last thing I'll just mention before I answer some questions is that if you are hosting your REST APIs in Azure, you can also use Azure API Management to basically create wrappers around different endpoints as MCP servers without having to write any code. So if that's the level that you'd really like to do this at, and you don't care about kind of changing the business logic, but just basically handpicking different verbs and endpoints that you want to allow, you can actually do that right in Azure API Management without any coding whatsoever.